All right, let's see where the law of sines formula comes from, proving the law of sines. So remember, the law of sines helps us to find missing sides and angles in oblique triangles, and the law of sines says A over the sine of A is equal to B over the sine of B is equal to C over the sine of C. All right, so why does the law of sines work? Let's see how the formula is derived. So I have an oblique triangle here that I have split into two right triangles using a height and altitude here, h. So I want us to look at these two right triangles individually. So look at the larger one here. And think about the sine ratio. So let's say we want to find the sine of angle A. Remember, sine is opposite over hypotenuse, so that would be h over b. And I can also go ahead and solve that for h by multiplying by b on both sides. So b times the sine of a equals h. And we're doing that for a reason. You'll see in a second. All right, let's look at this orange triangle now and find the sine ratio for B, which would be opposite over hypotenuse. Here's my right angle, so h over a. And again, I can solve for h by multiplying by a on both sides. So a sine of b equals h. All right, we know that if two things are equal to the same thing, we can set them equal to each other. That's the transitive property. So this expression is equal to h, and this expression is equal to h. Because both of those expressions are equal to h, I can set those expressions equal to each other. So we're getting closer to what the law of sines looks like. But remember the law of sines, we have a on top and b on top by itself. So I'm going to divide here by the sine of a on both sides. So now I have b over a sine of b equals sine of a. And then I'm going to divide by the sine of b on both sides. Those cancel, so I have b over the sine of b equals a over the sine of a, which looks very similar to the law of sines, which says a over the sine of angle A is equal to b over the sine of angle B. That's where the formula is derived. All right, let's look at the law of cosines. So remember, the law of cosines again helps us to find missing sides and angles in oblique triangles, and the law of cosines says c squared equals a squared plus b squared minus 2ab cosine of angle C. All right, so I'm going to start with this triangle here, and I'm going to set up the Pythagorean theorem. Now, I'm going to call this x, that little side, because it isn't labeled. So x squared plus h squared equals b squared, because that's my right angle. And then I'm going to solve that for h squared. So that's going to be my step one. Now I'm going to do the same thing with this triangle. Now, because we called this piece x, I'm going to call this side a minus x, because the whole bottom is a. All right, so this is step 2. I'm going to set up the Pythagorean theorem. And I put this in parentheses because it's an expression. Now, I'm going to substitute in this for h squared here. All right, and then I'm going to expand that binomial squared. And bring everything down. And then combine my like terms. So we have minus 2ax, x squared minus x squared, that actually cancels out. All right, and I'm just going to rewrite this with the c squared out front. And let's make it even more similar to the law of cosines. That's what we're trying to get to here, which remember looks like this. So we're very close here. The only thing is we have that x instead of b cosine of c. Well, if I come back up here and I look at the cosine of c, cosine, remember, is adjacent over hypotenuse, so x over b. I'm going to get x by itself here. So x is equal to the b times the cosine of c. So I can take that x down at the bottom and substitute it for b cosine of c. And there we go. That is how the law of cosines is derived.